Hello Year 5 and welcome to your Friday maths lesson with me, Miss Biggs. Can you please, as usual, record your date, learning objective. Today we're focusing on dividing with remainders. Write flashback 4 and complete your 4 questions here and the times. Pause the video and when you're ready, resume. Here are the answers to those questions. 835 millilitres poured equally means it's shared between 5 glasses. So we can see 800 and we divide it by the 5 gives us 160, and the 35 that's left divided by the 5 leaves us with 7, 167. Here 20 times 60, well, we can smile because we can do 2 times 6, which is 12, make it 10 times bigger and 10 times bigger again. Use this to mark your answers. Let's move on. So we are looking at dividing with remainders. Let's get started. First of all, let's warm ourselves up. Try these questions and then pause. When you are ready, let's look at the answers. 55 divided by 5, we know is 11 because 5 times 11 is 55. Have a look, what's the same as what is different? Well, it's still a number divided by 5 equals, now I can see an 11 here, like here, but it's 100 times bigger. So I'm going to do the same with this part and make it 100 times bigger. Here, how many 50s will fit into 550? We can have 11 of those. All these facts are linked. Let's learn for today. Let's use our learning to problem solve. Eva has 13 straws. She wants to make them into triangles. How many triangles can she make? Let's physically do it. A triangle has how many sides? You're right, it has 3. So we're doing 13 and we're dividing it into groups of 3 to make triangles. 1, 2, 3. That's made 1 triangle. 2 triangles. 3 triangles. 4 triangles with 1 straw left over. So she has been able to make 4 triangles with 1 straw left over. As a calculation, 13 divided by 3 is 4 with a remainder of 1 straw. So how many whole triangles can she make? She can make 4 whole ones. We don't need to worry about the 1 extra because it only asks us how many she can make. Use what you've just practiced to try these for Tommy, Dora and Jack. Pause the video, have a go. Let's first look at Tommy. Tommy has got 14 straws and he wants to make them into triangles. Triangles have 3 sides. So we're doing 14 and dividing it into groups of 3, each one making a triangle. Let's try it. Made 2 triangles, 3 triangles, 4 triangles, but we can't make any more. We have 2 straws left over. So, just like before, we can make 4 whole triangles with 2 straws left. That means we can make 4 whole triangles, and that's all it's asking us, how many can we make? Dora has got 1 more straw, so we can see she can still make 4 triangles, but she has 3 straws left, and we know 3 straws can make another triangle. So we can build 1 more triangle. 15 divided by 3 is 5. Dora can make 5 whole triangles. And Jack has 1 more straw than she had. So therefore he can still make 5 triangles and he will have 1 left over. So he can make 5 triangles as well. Let's have a look at this question. You will have one like this today. Could these calculations be correct? Now I want you to make a link back to what we did earlier in the week when we talked about how big could the remainder be when you know what the divisor is? And we learned that when we look at the divisor, that's the number we divide by, the remainder can only be up to 1 less than this. Use that fact to help you decide if these calculations could be correct. I do not want you to work out the answers. I want you to base it on what you know about the link between the divisor and the remainder. The divisor, the remainder. The divisor, the remainder. And from that, sort them into whether they could be correct or whether you know they are definitely not correct. Pause and try. Let's check. So, if we have a look at this one, if we're dividing by 3, can we have a remainder of 3? No, because that remainder of 3 could make one more group of 3. The lowest that the highest the remainder can be is 2. So this is definitely not correct. It goes down here. Let's have a look at this one. We're dividing by 4. Can we have a remainder of 2? Yes, because if we divide by 4, we can have a remainder of 1, 2, or 3. So this could be correct. This one, we're dividing by 5, and it says that it has a remainder of 6. Is that possible? Can the remainder be bigger than that? Well, no, because that remaining 6 could make one more group of 5 with 1 left over. So that is definitely not correct. Let's have a look at using our method again. Let's build 5,291, and we're going to divide it equally in 4. Remember our layout from our previous lesson in our formal method. Put the number inside and the divisor outside. Let's build the number 5,291. So we're looking at that 5,000 and we're dividing it into groups of 4. How many groups of 4 could we make? There's one group of 4. So we record that over here as one group of 4. And we have one of those left, which goes here as hundreds. So we need to move that across, and it becomes 10 hundreds. Added to the 200s that were already there, that makes 12 hundreds. 4 into 12 goes 3 times. The 3 goes here. There's nothing to exchange, so we look to our tens column. How many groups of 4 can we build? 1, 2. We can build 2 groups, and then we also have 1 10 left over. We're going to put that over here, but we're going to exchange it for 10 ones. Adding to the 1 we've already got makes 11 ones. 4 into 11, well, we need to group them in 4s. 1 group, 2 groups. There are 2 whole groups I can make, but I can't make a group from these. So these are what we call the remainder. So we will record that as remainder 3. So the answer is 1,322 with a remainder of 3 counters that cannot fit in. Your turn. Have a go at questions 1 to 3 on your worksheet. To look at how to lay that out in your book, please, you can pause and look at it on here. Now that you've completed 1 to 3 on your worksheet, let's continue on the next slide. Tiny Turtle says that 5,627 divided by 5 is 1,126 with no remainders. Is he correct? He's not correct. But why? Think about what you know about your 5 times table. That's right, the pattern in your 5 times table ends in a ones column with a 5 or a 0, a 5 or a 0, and the pattern repeats. Here in our ones column, it is a 7, so there would be a remainder. We know that the remainder must be 2. So therefore, 5 would go into 5 one time, it would leave us with a remainder of 2. Let's have a look at this question. There are 349 people at a wedding. They are sitting at tables in groups of 8. How many tables are needed? Think carefully about this one. Let's apply a method we know. We are going to be doing 349 divided by 8. Now, if you want to build it using your place value counters and grid, please feel free to do so. We are thinking, remember, of counting in our 8s. So think about your 8 times table when you look at this. How many 8s will fit into 3? How many groups of 8 can I make from 3? Well, I can't. I can't make a group of 8. So therefore, I need to record that as a 0 because I can't build it. So I have to take this 3 and it goes to here. So I now have 34 of those 10s. I now say how many 8s in 34. So count up in my 8s. 8, 16, 24, 32 is the highest I can go to. How many is that? That's 4 of them. There are 4 of those 8s in 32. But I still have 2 left over. So I put that there. How many 8s are there in 29? 8, 16, 24 is as high as I can go. And that fits in 3 times. That gets me up to 24. To get from 24 up to 29, what am I adding on? I'm adding on another 5. So the remainder is 5. Let's have a think. Do you think we need 43 tables? The answer is 43 with a remainder of 5. But what does that mean? We started with 349 people and we're sitting them in groups of 8. We've got 43 full tables and we have 5 people left standing. You wouldn't have that at a wedding. So we will need to have an extra table for these 5 people. That means we will have 43 full tables and we will have another table for these 5. So there will be some spaces on there, but at least they're not left standing. So we need 44 tables. Have a go at the rest of the worksheet. And I would like you, please, to lay it out like this. For example, record the numbers. Eva says that if she divides these numbers by 5, the remainder will be 1. I think she is correct because think back to what we just learned about when we divide by 5. How will we know whether the remainder would be 1 looking at these 1's columns? How do you know she would be correct? Have a go at the rest of the worksheet. Those who have the red level challenges, have a look at this. Stick each challenge in your book and then show your working or explanation at the side. Stick it in. And then I think the number is, give me what you've worked the number out to be, and give me your reasons why you say that. Use these clues to help you work out the number. Remember, it's a 3-digit number. That means it has hundreds, tens and ones. When you've worked it out, leave 2 squares and then record the next one. Is it always, sometimes, or never true? For example, this is sometimes true. And then you would need to give examples of when it is true sometimes. Give me an example. But then give me another example of where it would not be true. Because if it's only sometimes true, it means sometimes it's not true. Don't forget the last part of this question. How many possibilities are there? How many examples could you find? And I've asked, could you give me at least 3 or 4 examples? Some of you might astound us by providing us with more. Give us a sentence starter to introduce when you begin this. Here are all the possibilities that I could find. And then record your examples. We look forward to seeing those in school. Hope you've had a good week in your learning. Don't forget, everybody, to please complete your post-assessment on our block on multiplication and division, and then stick this into your book, please. Next week, we're going to begin recapping our work on fractions for Year 4, before we then stretch that learning up to cover our work on Year 5 fractions.